You may recall that the RCA video disc system uses a method of detection called the capacitance method of detection. And it is a sensing method which does not require physical contact between the stylus and the disc, so it works quite differently from a phonograph disc. And it's a proximity sensing method, and originally the RCA disc was a coated disc. I'm holding up one of the early discs, vintage about 2 or 3 years ago, that actually had 3 coatings of metal, a coating of dielectric, and a lubricant coating on each side. But I might add, even these discs could hold up to an hour of video and audio material on a side, 2 hours in total. By the way, they're grooved discs, approximately 9,500 grooves to the inch. I'm going to put this disc down because it's ancient history. We no longer have coated discs.
You mentioned to me before you put it down that these holes were also finger holes.
They were finger holes to facilitate the handling of discs, and as you'll see, we've come up with a much better idea that doesn't require finger holes in the disc. In fact, it makes the handling a new convenience. The RCA disc today is an all-plastic disc. You may be able to see some rainbow-like pattern. That's the diffraction of the light in this room due to the groove and signal structure in the disc. The disc is made of PVC. It's a polyvinyl chloride disc, and it has a constituent of carbon, which is highly conductive at the frequencies which are used to reconstitute the video picture. Some of those frequencies, by the way, go up to 1,000 megahertz. At ordinary frequencies or direct current, this disc, in effect, would be a perfect insulator, or a near-perfect insulator. It does all of the same things that the coated disc used to do. In fact, the disc can still be played interchangeably on the same player with the same pickup. The advantage of this disc is it is much easier to make. It is made like an audio disc in essentially a standard audio record press. Both sides are stamped out at the same time in about 20 seconds, and the disc is sprayed with a special silicone and open air, and that's all there is to its manufacture.
And there's no dielectric coating over it any longer?
No, there's no dielectric coating because the combination of PVC and carbon gives you the dielectric action that we had achieved before in a coating. Now, actually,
before you get to that, so the significant thing that has happened since that last disc is you've moved now to a new situation where you've got a much simpler disc that can be produced on standard audio record pressing equipment.
And in a standard audio plant. When I say standard, or when you say standard audio equipment, it's with some minor changing in the tooling, and I'm not implying that the same press would be used interchangeably for audio and video disc, but it is an audio record press with minor modifications. Right. By the way, it can use the same steam plant.
Yeah.
Now, I'm holding up this disc. Actually, the consumer will not handle this disc. The disc will come in a package called a caddy. It's extracted from this caddy automatically in the player. It's, and I will show you this later, it's simply done by pushing the disc into a slot in the player. In the act of pulling out the jacket, the disc is left behind in the player, and it's automatically dropped on the turntable. This player is a prototype. It's representative of several hundred players that we have built for complete testing of the system, which, by the way, has involved the pallet manufacture of approximately 250,000 discs. And this is to assure ourselves that the system will really work, that it be reliable, that it can be serviced infrequently in a consumer's home, that the picture quality will be superb, and so on. However, I want to tell you that this particular player physically is not representative of the product that we will introduce to the market, and a little later we'll give you a glimpse at a prototype which may not be precisely what we'll introduce to the market, but very, very close, and certainly representative in picture quality. Now, in order to put the disc in the player, I'm going to take the package, the caddy, and put it into a slot in the player, push it all the way in, and I hope you can catch on the monitor that a green light went on. I'm going to push the play button on the player, and I'm going to pick a place on this disc.
There's a marker there showing how that scale shows where you are on the disc.
By the way, you realize that the picture quality which you see on this tape is not the same picture quality which you see on the receiver, and you may want to comment on it. It has to do with the transfer from a TV receiver under bad lighting conditions to a tape.
I think all of our audience are well informed enough to realize that.
Now, what I'd like to do next is to show you the active search feature that I commented on briefly before. By pushing the active search button, I can scan this disc, and I'm doing this now. I'm going forward on the disc, and I'm just pretending that I went too far. I'm going to go back over some of the things that you may recognize as having seen previously.
Well, John, I think you can readily see that this player is about half the size of the older players that we've been using up until now. It is half the weight. As a matter of fact, this player weighs less than 20 pounds, and it consumes less than half the power that the older player, or somewhere under 25 watts altogether. Now, this is a styling model. Over here, John, we have what is the insides of the older type of player. This has over 2,145 parts in it. And I want to contrast this with the what is required to make the new player we've just been looking at work. And this is it over here. This is a plastic a mechanical model of the player. And what we have done, in order to reduce the parts count, which incidentally in this player is less than 700 parts total, and that includes every nut, screw, bolt, and washer that's required to assemble the player, is to do two things. In the electronics area, we have gone to integrated circuits. There are 7 of them in the player, which of course has made it possible to greatly compress the real estate required for the electronic components. 3 of the integrated circuits are off the shelf, and 4 are custom circuits. Now, they are represented, I don't know whether you can see this in the picture, by these little black cans here. And incidentally, John, that's an exact count of all the electronic parts required to make this player operate. So, take a caddy once again and insert it into the player, drop the disc on the turntable, which of course automatically starts the motor drive. And I want to show you a particular feature that the caddy has enabled us to accomplish in greatly simplifying the mechanical side of this player, because I've just moved the arm down to roughly half the way through the side of the disc, and I'm going to now change the disc, and notice what happens when I reinsert the caddy into the player. It pushes the arm back to a positive reference position in the back of the player. So that
Well, thanks very much, Jim. I would stress again, as RCA have kept on stressing to me, that the final product that appears may look slightly different, but basically it's quite a quantum leap from the other box in the corner there, the room which we saw, which is much bigger and much more complicated circuitry. I'm going to try and wrap it up now and wind it up there, and thank RCA for the terrific help and facilities that they've given in producing this program.